Okay, in this video we're going to look at upper and lower bounds. In this example it says a number has been rounded to 50 to the nearest 10. Show the range of possible values below. Now we're going to look at this in two ways. We're going to come back to this in a while and talk about it. But if something's rounded to the nearest 10 and your answer is 50, the smallest thing it could possibly be is 45, because 45 would be rounded up to 50, whereas if you had 44, 44 would be rounded down to 40. So 44 is not going to work. So 46 would also be rounded up to 50, 47, 48, 49, and 50 clearly is going to be rounded up to 50 as well. And 41 would round down to 50, 42 would round down to 50, 43 would round down to 50, and 52 would round down to 50, 53 would round down to 50, and 54 would round down to 50. 55 would not. So if you had 55, it would get rounded up to your 60. So it's not going to work. So there's the discrete numbers and the whole numbers, integer numbers, which round to 50. Okay, we'll come back and talk about this a wee bit more later on. Okay, this question says round the following to the required degree of accuracy. So this number to 2 decimal places. So it is 13.534 and you want to give it 2 decimal places. So how we set this out, we'll just say that's 13.534 equals, and I'm just going to put an arrow here at the 4. This is my third decimal place, it's my check figure. So because the 4 is less than 5, you round down. So it goes down to 13.53, and you must put brackets to dp. Likewise in this one, it wants you to go to 1 dp. There's your first decimal place here. So you go to your second decimal place is your check figure. So because it's a 1, we round down, so it's 7.0. A lot of people think you just leave that. So sorry, let me just say how we do this one. Set it out properly. We say 7.0146 is equal to, so my check figure is the second decimal place, and you round then down, so to 7.0, and you need that 0. So your answer is 7.0 to 1 dp. If you'd written just 7, that would be wrong, it would be incorrect. Okay, next one. It was 0.00543. So just write it out and then say what it is equal to the 3 dp's. So my first decimal place, my third decimal place is a 5. So my fourth decimal place is a 4, and it's a check figure. So again, we round down. So that's what it's going to be, and that's the 3 dp's. Okay, if you move on to the next one, it's to 1 sig fig. So first of all, the first sig fig is the first non-zero number that you come to. So 1 is my first sig fig. So that means the 3 is my second sig fig. It is the check figure then. So let's just write this one out. It's 1345 is equal to. So again, let's just highlight this is my check figure. So that means you round down to 1. But you don't just write that as your answer. Let's think about how silly that would be as an answer. I'm saying 1345 rounds to 1. It would be nonsense. So what you need to have is the zeros, and what the zeros give you is the place value of this 1 over here. So that 1 over here, it represented 1000. So that 1, you need the 1 with the 3 zeros to give you 1000. So it is 1000 to 1 SF, 1 significant figure. Okay, next one is 0.000708, and you were to round this to 2 significant figures. So my first significant figure is this 7, my second significant figure is a 0, so 8 is my check figure, so we'll get rid of those. 8 is my check figure, so it's going to be, so because it's an 8, which is greater than 5, that means you round up, so it's 0.007, and then my next 0 rounds up to a 1, and that's it. So that's going to be to 2 sig figs. Just to talk about this one again, my first significant figure is the first non-zero number that I come to, and again you need these zeros because they give you the place value of this 7 and the place value of this 1. Okay. The next bit of note says, when measurements are recorded, they aren't exact and are often rounded. So for height, for example, height is 173 centimeters to the nearest centimeter. The largest and smallest possible values, the actual value could lie between, are called the bounds. So the upper limit is a bound and the lower limit is a bound. So in this example, the bounds of 173 are 172.5 and that's because that's 172.5 is the smallest height, which would be rounded up to 173. But you could also have the upper bound of being 173.4, 99999 forever and ever and ever. So basically this bound is so close to 173.5 that we call it 173.5. Okay, so that's why this becomes this as the upper bound. So if we go back up top to this first example we had today, it said 50 is rounded to the nearest 10. So really, if this was a continuous thing, you would say that the lower bound really could be, we could say that the lower bound is equal to 45, because that would be rounded up to 50, and the upper bound really it could be 54.99999, etc., forever and ever, which is as close to being 55 as matters. So really, the lower bound is 45, and the upper bound is 55 strictly. But we'll just leave ours in our notes as that, and we'll just know we'll do this when we're on the questions. Okay, back down to this. We had said then that we had 173, we're rounding to the nearest centimetre. So that meant the lower bound was 172.5, the upper bound was 173.5. So what you've done there is you're going to the nearest unit. So if you half a unit, you get 0.5, and we've gone 0.5 either side of the 73. So 173 minus 0.5 is 172.5. 173 plus 0.5 is 173 plus 5. So it says when we give a measurement to a certain degree of accuracy, the actual value lies between the rounded value and plus or minus half the degree of rounding. So the difference in the bounds is usually the degree of accuracy. So find the upper and lower bounds for the following rounded data. So the first one, it's 105 centimeters to the nearest 10 centimeters. So what we want to do here is we divide this by 2 to give you 5, and then we just want to take that away. For the lower bound, take it away. So that's going to be 175 centimeters. And for this one, you add half of the 10 centimeters. Half of the 10 centimeters again is 5, and add that on this time. So that's 185 centimeters. For this second one, it's to the nearest centimeter. So that's 1 centimeter. Half of 1 centimeter is 0.5. So take 0.5 away from 180 to 179.5 centimeters. Add 0.5 on to 180, so it's 180.5 centimeters. Next one is the nearest 0.1. Half of 0.1 would be, so we're going to go plus or minus 0.05 centimeters. So take that away, you're going to have 180.25 centimeters, and added on is going to be 180.35 centimeters. And the next one is the 2 sig figs. So you have to look at what the actual thing is. So 2 sig figs, my second sig fig in this is where its value is 10. So we're going to go plus or minus 5 basically on this one. So in this one, it's going to be lower value, it's going to be 145 centimeters. It's not centimeters, it's just 145. And the upper value is going to be 155. Next one is 1 dp. So half of a dp, you're going to be going plus or minus, you're going to be plus or minus 0.05. So 1 dp would have been 0.1, so half a dp is half of that, which is 0.05. So you're adding and subtracting that away. So the first one is just going to be 15.45. That's my lower bound, and my upper bound is going to be 15.55. Okay, remember your units and all of these questions, and that is you ready to do your practice book, page 22, question 1.